Okay. We can start.
Yeah. So today, I would like to speak about Ethereum, like what it is, why it is called the world computer, and like some basic stuff about Ethereum and why it is so popular nowadays, and why you like have to learn it if you want to become a blockchain developer. So usually when you hear the word Ethereum, the world computer is often the first association that you have. But why is it? So let's start with some basic understanding of Ethereum, what it is. So we have a proof of stake blockchain with 400,000 plus validators. So it means that there are actually 400,000 like servers, nodes that run Ethereum. These are full nodes. Maybe some of them are Hive nodes. I will talk about what the full node or Hive node is in the future. But it is a really decentralized network. It is huge, and it is very secure. So the daily volume of transactions right now is about 1 million. When the market is hot, when the bull run is, this number can like be 10 times more. But right now the market is somewhat calm, and 1 million transactions is what we see today. And the gas fees are like mild. The cool thing about Ethereum is the Ethereum virtual machine. So basically, it is a special thing that the whole Ethereum is built on top, that enables smart contracts, that enables computation on Ethereum, and much more. Basically, it is the heart of Ethereum that drives it. Then there are several smart contracts oriented languages that are really high level. You can write like arbitrary code using those languages. They are pretty strict. Then you compile those languages into a low-level bytecode and feed it into Ethereum virtual machine that then executes this code, and that is how like Ethereum actually runs. And when you send transactions, actually those transactions are like executed by virtual machine, and that's how like everything runs there. Because Ethereum is like has been in a while for quite some time, it has developed a rich off-chain ecosystem consisting of a lot of applications, a lot of services. So a lot of people have taken their time to develop an amazing ecosystem that like anyone can use, and it is just amazing for the developers. Ethereum has really open community. Try a lot of groups, a lot of I know like Discord servers when you can join and discuss pretty much anything, starting from security and ending with some I know investment schemes that actually won't talk about in this lecture. What I want to say is it is a really huge blockchain with like really thousands of researchers, thousands of developers that come together to make this blockchain better and like drive the decentralized economy forward. So let's answer the question, why Ethereum is a world computer? And we have a diagram here. So this is our regular user that can send transactions. And there are actually several types of transactions that Ethereum has. We have like divided those into two big groups. The one that doesn't interact with smart contracts, the one that does interact with smart contracts. So we can send a transaction with pure Ethereum. Like if I wanted to send someone Ethereum, I would just use my wallet, said that one Ethereum like goes from my wallet to this account, and this transaction will go into the wild, and EVM will apply this change, basically decrements my account, like decrement one Ethereum from my account and increment one Ethereum on the destination account, and this will modify the Ethereum state. And there is a second type when the transaction actually interacts with some smart contract that is deployed onto Ethereum. I will discuss this briefly in this lecture, but in the future ones, we will probably cover the smart contracts in more deeply. So basically, this transaction can interact with smart contracts. The smart contract will do something that is designed to do. EVM basically reads the code that smart contract has, applies those changes, and once the transaction is finished, when it's added to a block, then EVM modifies the Ethereum state, applying all those changes that smart contract did. So from a computer science perspective, Ethereum is a state machine. Why? Because nothing can happen on Ethereum without a transaction. So in order to do anything, you have to send a transaction. Ethereum can't modify its state on its own. There are no callbacks. It can't react to off-chain events, and also it can't react to on-chain events unless there is a transaction. And between those transactions, there is a singleton state that is global to the whole Ethereum, to every node that runs it, and this state is readable through special protocols. And yeah, everyone can access it, no problem. So let's go to the next slide. Actually, if you have any questions, please interrupt me at any time and ask it. So let's have several topics discussed about the basics of Ethereum. So first of all, it is the currency that drives Ethereum. It is called Ether, or ETH. So it doesn't matter. It is the currency like Bitcoin. It's on a different blockchain, and it is used to pretty much to secure the blockchain, because the consensus is made on top of the incentives of not losing this currency, and also you use it to pay for fees, which are a bit different from what I have in Bitcoin. Ethereum, it is a cryptocurrency. It actually ticks a lot of boxes to be the one, and you can, I don't know, trade it somewhere. It is fully open. There is also the EVM. It is, as I mentioned, the heart of Ethereum, the computer that actually makes everything possible on Ethereum. It executes smart contracts. It is responsible for the updates of state, pretty much for everything. So there is also an important thing called gas. Actually, it is the unit of So this is how Ethereum estimates how much the transaction should like pay. So how much should you pay for the transaction in order for it to be included into the block? In Bitcoin, we have the size of the transaction, and also if you want this transaction to be included into the block faster, you have to increase the fee. Ethereum is a bit different here because each transaction can speak with a smart contract, and you don't know what this smart contract is going to do until you actually like see what it does. And this unit of gas actually says how complex the transaction is, how much work it does, and every transaction is like, okay, the gas can differ a lot. So if you want to send Ethereum, it is the simplest transaction that you can make. It will cost you 21,000 gas. And if you want to do some complex logic, some interactions with smart contracts, then it can rise like to millions of gas. Or if you want to deploy a smart contract, then it is really expensive. And then when you have this gas, you can set how much Ethereum you are going to pay for each unit of gas. If the demand is high, then this value will be high. But right now, for example, there is no such demand, so the gas fees are pretty low. So then there are two types of users on Ethereum. First one is the end user. It is called an externally owned account. It is the one that has the keys. It is the one who has the wallet. And actually, it is the one who can send the transactions, because smart contracts can't send transactions. They can only be in the parts of the transaction, but they can't form the like initial, so that they can't actually send them. They can only react. And externally owned accounts can be just regular users with the wallets, or this can be off-chain services by basically generating the keys on their own and interacting with blockchain like whenever they want. For example, they can listen to some off-chain events and react to them, and then place something on-chain. So, for example, the concept of oracles works like that. When the off-chain service listens to the price movement of Bitcoin, and then if the price crosses some line, then the service will create the transaction and place the price on-chain for its further usage. And smart contracts are the arbitrary programs that run on-chain. Those programs consist of like special opcodes. These are basically low-level EVM instructions that the program wants to add two values together, or it wants to read the state, or it wants to call another smart contract. And there is a set like of instructions, a special documentation, white paper, yellow paper that describes how this program works and how to like write smart contracts for this program to understand them. Yeah, this is all like available for the wide public, and everyone can learn it just by Googling. Okay, so Let's then compare Ethereum with Bitcoin. Oops. Yeah, so the first one, Ethereum is a proof of stake blockchain. So when the Ethereum was initially launched, it was a proof of work blockchain. So it had the like similar consensus to Bitcoin as this right now, the proof of work. In Ethereum, you also needed to mine Ethereum by constantly changing the hash output. But in Bitcoin, we have that the output has to lead like, so for example, this hash has to precede by 10 zeros or like one complexity, or by 20 zeros by another complexity. In Ethereum, they had like a completely different idea where they just had the random value, but this value had to be lower by a different value that actually Ethereum determines. If the load was high, then the threshold value like was low. If the load was low, yeah, then difficulty would rise, and it would be much easier to mine Ethereum. But on September 15th, 2022, Ethereum switched to proof of stake. It was a huge update, also known as the merge. Maybe you heard something about it. So basically, the whole consensus moved to a completely different thing. And right now it is proof of stake, and it is a completely custom proof of stake because it has to like run with so many nodes, like 400,000 nodes is really a lot. And this consensus allows Ethereum to run that many validators, and actually can do like much more because this consensus is really nicely scalable. And in order to participate, you have to lock the Ethereum. And if you do like badly, this Ethereum gets burned or just maybe locked like forever, and you will lose it. It has like really intricate rules, and it is super easy to lose Ethereum, but it is quite hard to gain it. And that is how like Ethereum is secured, because the token actually worth something and no one wants to lose it. Yeah. So the consensus with Ethereum is like a topic of a whole different lecture because it is like so complex. Then we have Ethereum is a deflationary coin, and Bitcoin is like inflationary, but it is a limited one. So why I think Bitcoin is inflationary? Because like as of today, the supply of Bitcoin actually rises, but at some point it will cap, and maybe after that the supply will actually decrease, and at that point of time it will become deflationary. But Ethereum today is already deflationary thanks the proof of stake and the concept of burning Ethereum that is used to send transactions. So when you send a transaction, you pay for it, and the part of this payment gets burned. And also proof of stake requires much fewer Ethereum to be given, because there is no electricity to pay for. You just have to run a server, which is like pretty cheap. So low low rewards, the burning makes Ethereum deflationary in the long term. So the supply may actually change, but in the long term, it will decrease. Bitcoin, sadly, not right now. Ethereum has a Turing complete Ethereum virtual machine. So this basically means that Ethereum virtual machine is as powerful as any other modern language and the Turing machine. So it is as powerful, for example, as C++. But of course, you can't run arbitrary programs there. Those programs are EVM specific and they only work on chain. So EVM doesn't know anything about the world outside. It can only interact with users, the Ethereum users, and other smart contracts. However, if you wanted to listen to something from the outside, you could use off-chain services like Chainlink and similar to that, because there is an ecosystem. In Bitcoin, we have limited Bitcoin script. It is far from being Turing complete. And yeah, it basically allows special rules to be defined in order to unlock the funds to be used. Then Ethereum is an account-based system, and Bitcoin is UTXO-based system. So let's start with Bitcoin here. In order to spend funds in Bitcoin, in order to send a transaction that spends funds, you have to specify pretty much other transactions in order to spend those funds. So I will remind that UTXO is unspent transaction output. So basically, to spend something, you have to know where to take it from. But Ethereum is simpler because it needs to have this Ethereum virtual machine running that can understand how to spend money. And the account-based system here is simpler in order to enable that. So what I mean here is that there are no unspent transaction outputs. There are just accounts and records in the database that this account has this much Ethereum. And that's it. Then Ethereum is mostly based on SHA-3 or Ketchup 256, and Bitcoin is based on mostly SHA-2, SHA-256. Both of those blockchains have an access to other hash functions, but what I want to point out here is that, for example, addresses of users and smart contracts and pretty much everything else, like transactions, private keys, public keys, everything is based on SHA-3 on Ethereum. Then let's compare the block times. So how fast is Ethereum? So right now, it is exactly, the block is mined at exactly 12 seconds. So why exactly? Because it is a proof of stake blockchain, and it is crucial for the proof of stake to have a fixed time mining blocks period. Before proof of stake, it was 13.5 seconds per block, and it was also deterministic, not non-deterministic. Right now, it is fully deterministic, and if your yeah, so basically 12 seconds per block. In Bitcoin, it is 10 minutes per block, but also like it can vary due to the proof of work, because one miner can mine it faster or slower, and Bitcoin will adapt to the speeds of mining. Then there is finality. So in Ethereum, there is a point where the finality of the transaction is 100% guaranteed, and it comes at 32 blocks above the block that your transaction got mined in. And Ethereum achieved this with its proof of stake consensus. Basically, blocks are called slots in the terms of consensus, and each 32 slots there is an epoch. And in order to validate an epoch, 2/3 like of all the validators, like 2/3 of 400,000 validators have to vote in order for this epoch to be like finalized. And if another epoch comes on top of Ethereum, it means that 2/3 of validators voted on the first epoch, 2/3 of validators voted for the second epoch. And there is an intersection between those sets. It is 1/3, and this is what guarantees the finality. Because in order to break the finality, you have to own more than 1/3 of validators, and it is just like a lot of money, because every validator has to stake 32 Ethereum in order to become a validator. So you can multiply 1/3 of the 400,000 by 32 Ethereum. It's like so much money that it is basically impossible. Bitcoin has probabilistic finality, and I believe it is usually like 4, 5, 6 blocks, and after that, the reorganization of blockchain is like probably won't happen, but so only probably. Oops. Yeah. So, and what about scalability? Ethereum is relatively scalable compared to Bitcoin, for example. Why? Because, for example, because it is a proof of stake blockchain, and you can basically it enables updates to be made on blockchain like easily, and a lot of preparation has been made for the Ethereum to become like really scalable, and this will only happen when the blockchain is kind of deterministic. So right now there is one blockchain, like mainnet Ethereum, where all the transactions are, but in the future there will be special shards that run like in parallel to the main chain, but those shards will act as the storage. So you won't be able to like send transactions to those shards. You'll be able to only store something in them, and those shards will store the data from the layer 2 solutions that are based on like zero knowledge proofs or something like that. It's like the future region of Ethereum. Probably like in the next 5 years, we'll see something like that happening, like another, I don't know, huge update on Ethereum. But right now, it's only one blockchain, and you like can't scale this one blockchain. It will stay the same. In Bitcoin, is like poorly scalable comparing to Ethereum. Like a lot of work with Bitcoin script is done to make like to optimize something, to optimize the signatures and other stuff, but actually it's like not really well scalable. Yeah, okay. So let's go next. Yep. So here is an overview of Serum Ecosystem. Of course, it is not full. It's just like one image from the internet, but you can find like more images with different names of the different protocols. So how did Ethereum actually become this huge? This is because of, first of all, EVM that enables arbitrary computation to be made on-chain, and a lot of protocols, for example, Uniswap, really works well because of the arbitrary computation. Uniswap, it is the decentralized exchange. So basically, it has special smart contracts that do all the exchange stuff, and they can work with money, with assets that you can create on Ethereum as well. For example, assets like DAI or USD coin. Those are basically smart contracts that are present on Ethereum, and they tend to mimic the price of USD. So the price is mimicked via arbitrage, but what is important to understand here is that it is a smart contract that is programmed to behave like a dollar. And because Ethereum is an open platform, and it's an open blockchain, anyone can create like pretty much any assets and do whatever they want with them. Also, drop protocols like on-chain insurance. For example, Nexus Mutual is the protocol that allows insuring on-chain assets. So, for example, if you want to ensure that price of USD coin will not depeg, it will not drop from the $1 equivalent, you can do it with a Nexus Mutual service. For example, what do I have here? Okay, so for example, Gnosis, it is also a huge service with layer 2 blockchain, the blockchain that runs along the Ethereum, but with completely different consensus mechanism, but uses Ethereum to like snapshot its state like from time to time. And Gnosis is responsible for one of those chains, and it is like a like guys who have been on the market for a while already. Also, there is, for example, Maker and Compound that are basically banks on Ethereum, where you can give them some tokens, Ethereum or any USD, and like to deposit those tokens. And they will give you something for credit. This is also like all done with a Solidity language or Viper language. Like pretty amazing that you can do this on chain, and the Ethereum allows those really hard and complex concepts to be like brought on chain. Also, drug custodial services. This is the famous MetaMask wallet. Actually, I think it is the most popular wallet on the Serum ecosystem. It's available as extension. You can just download it in your Google Chrome and it will work brilliantly. There are several other wallets like Trust Wallet, My Answer Wallet, and other ones that just work with Ethereum really well. Also, we can take a look at some marketplaces. For example, OpenSea, the most popular NFT marketplace on Ethereum. Also, completely decentralized. There are special like smart contracts developed that can trade NFTs, where you can place some orders, match orders, and other stuff. Also developed with the same languages. So I hope you had an overview of the ecosystem. So I personally don't know a lot of projects that are mentioned here, but I think like all of them are really nice. Yeah. So like some facts about Ethereum. So Ethereum was conceived by Vitalik Buterin in 2013 and developed by Gavin Wood as CTO in 2014-2015. Then Ethereum was launched on July 30th, 2015. Ethereum is not a platform that was developed and then forgotten. No, it is under constant development. For example, the Solidity language is like always updating with new versions. Ethereum is constantly updating with hard forks and some innovations brought into the system. There is a nice roadmap actually published by Vitalik Buterin describing what will we see in the future, and it's like a really amazing open source live project that anyone can contribute to. Ethereum popularized the DeFi because Ethereum is an open decentralized blockchain which can run arbitrary codes. It was the place where those protocols could work their way through by developing those amazing concepts and amazing smart contracts and translating them into decentralized finance and creating those cool ecosystems where one application can interact with another application to build another concept. Then there is a completely different application that can refer to any of them. So it is just really cool. DeFi has there are special concepts that DeFi follows. Those concepts are written in Ethereum improvement proposals. When the NFT is actually an Ethereum improvement proposal where you can read through it and understand how to develop exactly the standard that the DeFi will understand. Or if you want to use, the USD coin, the USD coin follows the special standard, the ERC20 token, that you can also read through and understand what each function does. Then right now in Ethereum smart contracts, 30 billion, like equivalent of $30 billion of assets are locked. Basically, it is the value, the like cumulative value of tokens that are locked in decentralized finance as, I don't know, as liquidity or as deposits or as something else, you know, staking. But the number is really amazing. And right now it is actually the bear market. So in the bull run, the value was much, much higher, maybe 10 times higher as this. But yeah, still amazing. And then there is statement that Ethereum is very attractive for hackers. Yes, it really is, exactly because of this huge number that is locked in the smart contracts that are available for everyone, for public to read, and only the code that is written in those smart contracts is the code that will be like executed. So if there is a way to sneak into the codes, or I don't know, find some ways to manipulate any prices or manipulate the application, hackers will do it, like definitely. And I believe only in 2022, I think like almost $2.5 billion was stolen by hackers. It is not the value, like it is not the Ethereum, the EVM that was hacked. No, it is completely safe and secure. But I'm talking about the smart contracts, like the actual decentralized applications, like Uniswap or like I don't know, bridges. And those protocols were hacked for like $2.5 billion in the last year, which is an astonishing number, and I believe it will only grow because of the adoption and because of the interest in Ethereum. And as we mentioned previously, Ethereum switched from proof of work to proof of stake on September 15th, 2022, and this like occasion is known as Zimmerge. I think it is one of the most brilliant updates we have ever seen, because like just think of it, the blockchain that holds billions of dollars in their smart contracts and billions of dollars in the native Ethereum currency just like changed its consensus like in 1 second. And in order to do this, like was done for 4 years, I think. First they like thought deeply of each like step they wanted to take. Then they launched the proof of stake chain separately that was called the beacon chain. Then they launched those beacon chains on test networks. Then they switched test networks one by one, carefully like analyzing what's happening and like how to mitigate any problems. And then they announced that the merge like is happening when the total difficulty achieves a certain point. And this like happened on 15th September. Actually, I was watching it live, like watching the blocks to mine, and then like the first block was mined with proof of stake. It was amazing. It's really, really great achievement by the developers. Okay. And the last slide. So why actually learn Ethereum? Because Ethereum, it is actually the innovation. You never know what is going to be around the corner. So you can develop new protocols. You can become a cryptography researcher. You can become an on-chain security specialist. You can become a white hat. The white hat is the one who helps projects to like mitigate the bugs. And for example, in a Black Swan event, when some funds leave the protocol due to some hackers, the white hat is the one who saves the protocol. You can become just a Solidity developer or any other developer who works with Ethereum. It can be like actually a Go blockchain developer who's going to write some off-chain services for on-chain stuff. Maybe you can become a DeFi expert to find those ways to, so because the ecosystem is so huge, of course, there will be a chance that doing a thing in one protocol and then doing another thing in another protocol will bring some value. And it is like unsolved things that everyone can try to solve and find any opportunities that are present on chain. Okay, so actually that's it. So if you have any questions, feel free to ask.
We have one question in the chat about Terra.
Mm-hmm. Yeah, just let me.
Is Terra dead?
Is Terra dead? This is a pretty nice question. So I thought it is dead when it collapsed because of some strange consensus of the blockchain and other strange stuff that just shouldn't work. But right now they launched like Terra version 2 with a different consensus, and like I heard that some developers actually build something on Terra. So I think it is not dead, but and it is actually like great that there are those blockchains that are not only like monopolized by Ethereum, and they have like different ecosystems. It is actually amazing. But in terms of Terra, it is like a speculation.
Okay. Maybe some of you have some question. Okay, Ihor Shukov, please.
Sorry, but I missed the point. Why Ethereum smart contracts is vulnerable, and it said that hackers can always throw this money which we put for smart contracts. I didn't get it.
Mm-hmm. Okay, so there may be several like problems with smart contracts, why they become vulnerable. But the main problem is just inattentiveness of developers. So basically developers forget to I don't know, say that you can't withdraw money, and they forget to restrict the contract to not give you money. This is like the most common problem, and this is why a lot of projects ask for an external audit, where special folks would take a lot of time to like meticulously look through the codes and understand how each line works, and then create reports that, okay, there is a problem, you have to fix it, or okay, they think that the protocol is fine. Then there are problems when the developers actually either don't completely understand or don't like know what the particular features of virtual machine do. And they use those features, but they don't know all the aspects of how to like properly use it. That is another problem. And also like there are bugs in protocols that no one can find and no one has found, that are just there, where the hackers use those bugs to somehow influence the behavior of the application in their favor.
Okay, and I don't remember like alternatives, but if used not Solidity, maybe it's Cardano, but I can be wrong. And they use sort of like a functional programming language, which is more safe as far as I understand. Can you give any comment on that?
Yeah, I believe Cardano uses Haskell.
Yeah,
I'm not mistaken. Yes. So yeah, Haskell is a functional language, and actually functional languages, like they restrict the behavior of the program in some way, but of course there is room for bugs, there is room for just mistakes, and it's actually pretty normal. In like huge applications, there is no way there are like no bugs. If the like protocol uses 50 smart contracts that somehow work together and use other protocols to also do something there, like there have to be some bugs for sure, because like we are humans.
Totally agree, thanks.
Okay. Ihor Zhukov, do you have one more question?
Oh no, sorry, I should just lower my hands.
Okay, thank you.
There is something in the chat.
Do you see the chat? Yes.
Yeah. Why are there so few successful decentralized exchanges? Is the challenge building them technical or something else? Yeah. So there is one decentralized exchange that basically ticked all the boxes, the Uniswap, and it is just the concept that they used. It is one of the best that can be used on chain. It is like so successful, and it is really, really hard to develop something better. Like you have to spend, years of research and then development to somehow beat those protocols in some way. Either it is the fees that the user pays, or it is some other features that the Uniswap lacks. But as I mentioned, it is really hard, and there are few exchanges that took the market from the Uniswap. For example, Curve, because it used like a slightly different model, but a completely different approach to exchange assets that have similar value. For example, stable coins. So Uniswap was bad at this particular task. So Curve saw the opportunity and developed their own. But right now there is Uniswap version 3 that is much more competitive to the Curve, and it like ticked even more boxes. So that's why it is so hard to compete. But we still don't know. So it is like an open question how to optimize the exchange of tokens. And maybe in the next year we'll see something groundbreaking and Uniswap would seem obsolete. I don't know. Yeah, you're welcome.
Okay. So maybe this is the end of our meeting, of our lectures. Thank you for a lot, Artem. Thank you for your time. Thank you for all, and see you on Thursday. And I will add all materials to Classroom. You have a test for this topic and this presentation and video. Goodbye and have a nice day.
Yeah, thank you. Bye.
Bye.